hopefully I'm not too far out of practice. I had the pleasure of being a keynote here a couple of years back. I guess it was 2019, maybe 2019. So, yeah, it was a great experience for me, and I have a wonderful plaque that graces my office. So, let's see here. Let's advance the slides. I figured I'll start with a quick update of where HD radio is in North America, starting, of course, with what we have done so far. The technology is approved in the United States and in Mexico. It's experimental in Canada. In the U.S., we have 2370 stations on, with a total of 4,552 digital channels. In Mexico, 123 stations on the air and 201 digital channels. In Canada, I'm happy to announce that we now have 40 stations on with 88 digital program channels available, and that's covering quite a few markets, so we'll look at those in a little more detail here. We have a total of 16 markets that are covered with HD. In those markets, we have a total of 40 stations, reaching approximately within those city limits, about 10.8 million in population, and happy to report that 40% of new car sales in Canada are coming with HD radio technology. Many of those models now are standard. There's 33 auto brands and 112 models. In Mexico, similar penetration as far as the auto penetration, 40% on vehicle sales in Mexico. And there they have 123 radio stations on, and their population reaches about 50.5 million. In the U.S., we have a total of 412 HD radio vehicle models available. 193 of those are standard, and the majority of those are vehicles under $35,000. You may have heard recently that Toyota announced to standardize HD radio in their entire product line beginning in 2023. The penetration for HD radio cars delivered in the U.S. is around 57%, so it's a little higher than it is in Canada and Mexico. We have an annual take rate of about 9 million, and this is the 2021 number. I just heard before I arrived here that we're at 90 million vehicles sold with HD radio technology. And in some of the markets, the penetrations are pretty significant. Typically, New York and LA tend to be, the dominating markets. New York's at about 44% of the vehicles on road have HD radio technology in them. But there are some outliers, like Burlington, Vermont. Burlington, Vermont has almost 40% market penetration. So I can't even just say it's all just in the large markets. It's becoming pretty significant. But not wanting to rest on our laurels, we really needed to look at where will this technology go in the future. We have a lot of competition. Certainly streaming services, ATSC3, which we'll hear a little bit about later today with Perry. All of these things are starting to compete for listener attention, and that attention is not just limited to audio, it's including video and visual elements. The lines between technologies are beginning to gray. What is television, what is radio, is starting to become a very difficult thing to be able to really clearly define. So back in around 2014, we started an effort to look at what could we do to increase the capacity of the system. And our goal was to unlock more digital capacity for emerging market needs. And some of those needs are yet to be defined. You may have seen an announcement on CNN yesterday that they are going to eliminate all internal combustion engine vehicle sales by 2035. And they're also going to strategize on how to remove all of the existing platforms. Well, that's going to create quite a bit of a burden to the electric grid if everyone is going to be plugging in a vehicle when they get home at night. And at the same time, they're also eliminating water heaters that are gas-fired. So now an electric grid that can't support air conditioning and computer needs and everything is now going to be burdened even more. So what could be done? Well, being able to make those vehicles and end devices more intelligent by transmitting data in a one-to-many fashion enter broadcast radio, is a great vehicle to bring that information to the market and be able to control these grids in efficient and planned ways. So some of the design characteristics that we looked for in our existing system, we use QPSK, 1-bit I, 1-bit Q. We can increase the capacity by going to a 16 QAM configuration where we have 2 bits for I and 2 bits for Q. Now the challenge is, as we go to these higher order modulation schemes, is that the effects of noise and the ability to resolve the signal become much more difficult. We can also go to 64 QAM, as ATSC does. And so we have the ability to now take the capacity of the system up threefold. But as noise increases, it becomes much more difficult to pull that signal out of the noise. So the robustness at the higher order modulation schemes becomes quite a bit more difficult. We are utilizing a number of error correction methods, one of which offers frequency and time diversity, as well as the actual sequence in time shift. So in addition to using Reed-Solomon coding and so forth and using much longer spreading codes, we're able to offer time diversity in the transmission. So it becomes much more robust. One of the tricks to all of this is adding backward compatibility. And so we went to a methodology of using layered modulation schemes so that existing receivers continue to function within their normal capacity, and the newer receivers get the benefit of the additional modulation layers that lay on top of that. So the legacy receivers continue to get the signals that were being broadcast today, the QAM, and as we go to the higher order modulation, we're able to add all of that additional capacity. So just a quick review here, because I don't want to dig too much into Donna's time. Our existing MP1 mode, we have about 99 kilobits per second. In mode MP11, which is the highest capacity hybrid mode, we have about 149 kilobits per second. In mode, in the all-digital modes, this is MP6 mode, we would eliminate or have the ability to eliminate the analog signal, and the intent originally was for that analog spectrum to be replaced by a digital waveform. So what this allows for is a market-based transition of the... Ron, did you have a question for me? Oh, okay. It allows for a market-based transition to an all-digital world. Not something we're dictating, likely not something the regulators are going to dictate, but when market conditions are right for that additional capacity and need. So within the spectrum that we used to call the MS modes 1 through 4, we have now introduced a mode called MS5. And with MS5 and MP6, we have the ability to deliver about 215 kilobits per second of data. But not stopping there, we can also then go into these layered modulation schemes. Here we have the ability to deliver almost 331 kilobits per second. And of course, these are less robust as we're going to the higher orders of modulation. But imagine now being able to also send video within this. It also creates an opportunity for the technology to be, much like 5G is, a venue technology. Something that is good where you have high levels of signal and need the ability to deliver a lot of content. The layered modes go all the way up to about 464 kilobits per second. Once again, these are not going to have the same coverage area. Now, we have gone from the lab test and have moved on now to actually do testing in the field. So in Frederick, Maryland, we're operating on effectively it was a translator at 94.3. It has an analog TPO of 60 watts and an ERP of about 55 watts. The digital transmission is currently on the primary at 36 watts and on the secondary at 3.6 watts. And you can see the worm trails here on the coverage are out almost to 20 miles or beyond, even in the higher order modulations, and that's with less than 5 watts of digital. So here's the actual coverage range for those new modes. These are early days. We're not saying this is ready for commercial deployment at this point, but it's looking really promising, and it is going to be going into the receiver code loads so that we have the receivers ready for the manufacturers to be able to build transmitters that support this technology. So we're trying not to rest on the laurels. We're giving you a vision for where the technology can go, and most of these higher order modulation schemes are going to be areas where you have higher signal levels that can offer higher levels of service. Thank you.